G'day folks. I was asked by somebody in my Extension 2 class about parametric equations of 3D vectors. This is about I gave up after about the fifth time of trying to draw 3D vectors on the board. What can I tell you? I did my best, but my drawing skills aren't exactly what they should be. I did a search on YouTube. I found a fantastic channel called Root Math. So hat tip to you, Root Math. Excellent work. Love your channel. I've dropped you a subscription. Anyway, look, I've got a link to the Root Math's video in the description of this video. So it's the very first line of my description. Have a click on that and watch his video. What I've done, I did something that I went sort of one step beyond what he did. He ended up with a parametric representation of the 3D vector that he was after. So the problem we were looking at was going from 3D parametric representation of vectors into a non-parametric representation. So eliminating the parameter, so just expressing our line in terms of x, y, and z. I did one step beyond what he did. I actually got the three vectors that he did in parametric form, and I resolved them down into just the one equation of the line in x, y, and z. So you get a complete picture. You watch his video. When you finish his video, come back and so you can hit pause if you like, go and watch his video and then come back to here. What I've done is I've taken the three parametric equations that he ended up with for the problem that he was answering in the second part of his video. So he had x equals 1 plus 3t, y equals negative 1 plus 5t, and z equals 4 minus 2t. And what I've done is I've gone through and I've shown how we go from that into our x, y, and z coordinates. So eliminate the parameter. So just working through from equation 1, t is x minus 1 over 3, and just sort of separating that out. T is a third x minus a third. I call that equation 1.1. Now I'm going to substitute 1.1 into both equations 2 and 3 up here. So into equation 2, I get y equals negative 1 plus 5 times t, which is a third x minus a third. And then I expanded and simplified that. I've got y equals 5 thirds x minus 8 over 3. And I call that equation 4. Okay. Then I substituted t, like I promised I would over here. I substituted t into equation 3. That happens over here. So in equation 3, I had z equals 4 minus 2t. So I had z equals 4 minus 2t, which I got from 1.1. And I expanded and simplified that. I've got z equals 14 thirds minus 2 thirds x, and I called that equation 5. Okay. Now, having a look at equation 4, I rearranged equation 4 to make the 8 on 3 the subject, and then multiplying by 3/8, I was able to make the subject of this equation 1. So multiplying by 3/8, I got 1 equals 5/8 x minus 3/8 y. And I call that equation 4.1. I then modify 4.1. What I'm looking to do, okay, so let me say a bit, why are you doing this? Well, look what I've got. Equation 4 is y in terms of x. Equation 5 is z in terms of x. Well, I want x, y, and z to be in the same equation together. Okay, so I notice that in equation 5, I've got a 14 on 3. So I'm going to manipulate this 8 on 3 to be 14 on 3 from equation 4. So I'm going to get this 8 on 3, manipulate it to be 14 on 3 in terms of x and y, and then substitute it into equation 5. Okay, so that's what I'm doing. That's the rationale behind what I'm doing now, right? So multiplying everything by 14 on 3, there it is, multiplied by 14 on 3. Expand and simplify, I get 14 on 3 is 35 on 12x minus 7 on 4y. I call that equation equation 4.2. Well, now this thing, this 14 on 3, which is that term in x and y, I can now substitute 4.2 into equation 5. And so in equation 5, where I see a 14 on 3, I instead write 35 on 12x minus 7 on 4y, okay, minus 2/3 x, which is that there. And then I just basically simplified, so 35 on 12x minus 2/3 x was 9 over 4x. Multiplied by 4 to get rid of the ugly denominator. And then I just rearranged. So I got 0 equals 9x minus 7y minus 4z. And I got my equation with the parameters eliminated. So I hope that helps. Let me know how you're getting on.